Now, ladies and gentlemen, the one joining us on stage is founder and CEO of KILT Protocol, previously served as the CTO of Hubert Berta Media, where he initiated and headed the Drupal-based CMS Thunder. Earlier, he was a IT project director at Axel Springer. He'll be speaking on importance of decentralized identity. May I request you to please put your hands together. Give a big round of applause to the founder and CEO of KILT Protocol, Ingo Rube. Let's give a big round of applause to Ingo. Thank you so much for joining us, Ingo. How are you?
I'm fine, thank you. Hello. Yep. Mic is also working.
Yeah, working. You like your voice? You want to increase the volume for Ingo a little more? Yeah? You want to say hi to everyone, Ingo?
Hello. Yeah, I think it works fine. All good.
Perfect. Ladies and gentlemen, Ingo for you.
Yeah, good morning, everyone. Slides coming up. Yeah, cool. So I'm Ingo. I'm the founder of KILT Protocol. How does that hang together with Polkadot? KILT is a parachain to Polkadot. So we use the Polkadot technology to actually secure our network. And we've been there from the start, I think. So I think we were the first project to actually use Substrate as a technology to build their own blockchain. Today, I'm not going to talk about too much about why Polkadot and stuff like that. I'm going to talk about what is identity? Why is it actually important that you think about identity, and why is it important that we do what we do? So let's start off with what is identity? I think that's a philosophical question, and everyone has a different answer to that. But there's also a common answer, probably, and I'm trying to explain that in form of this little guy called Archie. So Archie definitely has something like a face, and he has something like a fingerprint, and he can do a unique signature. And this identifies him. This is not identity yet. This is identifying him, because Archie has a unique face. That's cool for him, because everyone can identify Archie, and no one can fake Archie, and Archie controls the face himself. That is very decentralized, right? So no one gave it to him. No government gave Archie the face. No company gave Archie the face. No blockchain gave Archie the face. It's his face. He made it himself. So now we can identify him. But then also, that's not enough. For identity, we also need something that we call credentials. So for example, he has an identity card because he lives in the kingdom of Rohan, and he also got a university degree. He's a ethologist, and this was issued by his university, and this was issued by his government. So there's different issuers for these things, but what's cool about all those credentials is that he actually owns them. And he can have tons of them from different entities. So he got one from the fishing department here, and he got one from the bank so that he can pay things. And these credentials, they group around the identifier. As you have seen, for example, on the passport, there's a picture of his face, right? This is what links the face, the Archie together with the credential. And he holds the credentials in his pocket. So he decides when to show a credential to whom and for what reason. So very autonomous, very decentralized, because more decentralized than a single person it will never become. So actually a pretty cool system we had in the old physical world. Now, let's look at this physical world and how we use such a credential, what we call an identity transaction. So, So say Archie is going to Mary's whiskey shop, probably because he has an appointment later on with Gavin and wants to bring some whiskey. So he has to be 21 or 18 or whatever to buy the whiskey. So what he does, he shows one of his credentials, probably something like a government ID. So he takes the government ID, and then a strange thing happens. In seconds or in half a second, Mary checks if he can buy whiskey. How does she do that? So first of all, she looks at his face and she looks at the credential. Does the face match? If it matches, then the identifier is already okay. Nice. Second thing is does she actually trust the issuer? So is this a plaything just from a board game or something? Or is this actually issued by the Kingdom of Rohan, which she trusts probably? It's the Kingdom of Rohan, so she trusts, totally okay. Second thing, she looks if the credential is actually okay. So there might be something like a holographic thing here, which she moves around and stuff like that. So is this a fake? Did Archie make it himself? Yes, no. No, it is probably legit, so credential is okay as well. Next thing she checks. Is the content okay? So she looks at the date of birth and sees, is he actually 21? So he's born in 2000, so he's definitely 21. So he can buy whiskey. And then, this sometimes works. Then she checks if the credential is actually a valid credential, so it expires in 2023, so it's good to go. So now Archie can buy the whiskey, which is happening in just a second. She just looks at it and says, yeah, it's okay. And this is very, very powerful because she just interacted with Archie. The government of Rohan was not part of the transaction. So the government of Rohan will never find out that Archie bought a whiskey. That gives a lot of privacy to him, and it also makes the whole system very, very scalable. Because millions of people can go to millions of shops at the same time without the server of the government breaking down. And also, the information stays just between Archie and Mary in this case. Very, very cool thing. So physical world isn't always as bad as we think. What we have in the physical world is we have a decentralized system, we have the user in control of their identity, we have a secure system, it is very privacy preserving, and it is very scalable. So now, as we know how cool the physical world is, let's look a bit at the digital world, especially the one of Web 2. So in the Web 2, in the 1990s, some of you might have experienced that. We had different logins. We had a login here at Amazon, one at Microsoft Network, one at Google. And that was very cumbersome for people because they always had to remember the passwords. They had different digital identities that will not converge. They couldn't take information from one organization to another organization. So something happened. And in the current world, we have those centralized identity providers, for example, Google and Facebook. You've seen the buttons, log in with Google, log in with Facebook. Totally practical, no question about it. But, and then you can log in with those things to many different services, right? So, but somehow this puts Google a little bit in the center and Facebook, and this might be dangerous. Let's think about that. How does that technically work, just for the tech people? So we always have, so the protocol we use there is called OAuth. We always have an identity provider and we have a relying party. So the user, Archie, goes to Google, gets his identity token, which is stored in the browser, and then he can use this at the relying parties, and there's a trust relationship between the relying party and the Google. And that's basically it. But the problem in that is that Google, in that case, is the controller of the identity. There is no phase which I own. There is just an entry in the database of Google, which Google owns. And this is dangerous because Google could potentially just switch my identity off. And when digital identity becomes more and more important over time, then not really a good idea to have one company controlling the identity of billions of people. And another thing is when Mary's whiskey shop online uses the Google login, then actually there's Google always between her and the customer. So it's actually not her customer anymore. It is Google's customer. And Google can use the information that they collect about the customer for example, profiling, and tracking and tracing and even monetization of this user. And this is actually something that Mary should do, because Mary is actually the counterpart. But Mary is left out. This is not good for Mary, and this is not good for Archie. So we have to do something against that, apparently. So what do we have in the digital world today? We have a complete centralized system. The data in the system can be misused for things that the users actually don't intend. We have single points of failure. We have a non-secure system, and we have a non-scalable system. So pretty interesting, actually. We went from a very, very cool, decentralized, futuristic system in the past to a totally centralized, anachronistic system in the present. So we're making steps back and not forward. So how can we, so this is now the reason why we did all the work, right? Now you understood the problem that we found and that KILT is trying to solve. So the first thing is that we use DIDs. You probably have heard of DIDs. That is an international standard how digital identity, decentralized identity should actually look. And big companies are jumping on that. Governments are jumping on it right now. So it is the international standard. So what we implement is DIDs. The important thing about a DID is that it lives in your wallet. That means that you do not get a DID assigned. If somebody ever comes to you and says, I'm going to assign you a DID, go away. He's not using it in the right way. You make your own DID on your computer, on your mobile device. If you don't make it yourself, then it's not a DID. So it becomes like the face or the fingerprint. The DID consists of two different things. It has a public part. Public keys and stuff like that, they are stored on a blockchain, so they are public, they can be seen. And then there's a private part, like the private keys, which sit on your wallet and nowhere else. You don't ever share it with anyone. Sorry for that. Now you have your decentralized identifier, self-made, on your own wallet. So Archie is getting a little bit much better than he was before, because it's not at Google anymore. It is like he has created his digital signature and his digital face at the same time. Thank you. The next thing that you can do with the DIDs is that you can add verifiable credentials. So the first thing that you may want to do is that you go to a KYC provider. We have the guys from Deloitte sitting here. You can talk with them later as well. They are a KYC provider. So you go there, you make the KYC process once, you get your verifiable credential. The verifiable credential is like your digital passport. This passport is then added to your wallet. So it sits on your wallet. It doesn't sit with Deloitte. It sits with your wallet. You decide when to show it, where to show it, to whom, and for what reason. It is yours. It stays here, and you can show it for many, many reasons. This credential is then approved by the KYC provider, and it is anchored on the blockchain. Anchoring means that there's just a hash of it on the blockchain. The information, the private information itself, is only with you. But the validity of the credential is stored on the KILT blockchain. Of course, you don't do that only with Deloitte. You do that with many, many others. And there's huge business down there. So if you want to make business in credentialing, like credentialing that somebody has an ability or has done something or has been somewhere, you can just become one of those issuers. Anyone can become an issuer. Issue credentials to people like Archie who collect those, like you collect in your physical wallet, and they are all hashed on the blockchain. So this is basically how it works. A DID, just 2 minutes about DID. DID is a very, very powerful concept. So a DID in the center, it can hold all the verifiable credentials, or it can connect to all the verifiable credentials. It is like the picture of your face on your passports. But you can also have human readable names like W3N, which is Web3 name Archie. You can attach addresses of different networks to it, for example, Bitcoin, Ethereum, Polkadot, KILT, so that those are basically your bank accounts linked to your identity. And of course, you have the key pairs. So very powerful thing, not comparable with a crypto address, much more energy in this thing. So for example, it just has the ENS built in, right? So that's quite nice. How does the identity wallet look? Well, like that. In the end, like your personal wallet that you have in your pocket, you have an identifier in the middle, and then you have tons of credentials around that. So let's make the whiskey example online with verifiable credentials. So Archie wants to party again. So he goes to the online whiskey shop. No Google in the middle, no Facebook, nothing. And he shows his verifiable credential. So Mary now sees the verifiable credential signed with a DID. What does she do? Oops. First, she checks the identifier. Is that okay? So she basically looks at the face, but she does that in a technical way. She sees if the signature of this credential actually matches a DID on the blockchain. So that's okay. Then it's Archie. Then she checks if they trust the issuer. So it was a KYC credential issued by Deloitte. She probably trusts Deloitte, so she can go on selling. Is the credential okay? That is inherent, so it has a hash around it. Then is the content okay? There's content inside the credential, which says his date of birth was exactly that, enough. And then she checks the validity, and that she checks on the blockchain, is the hash okay on the blockchain, and is it active? So it is the same process, basically, that we had in the physical world, just digitized. And with all the freedom and all the liberty that the person in the internet actually should have. So in the end, he got his whiskey. So we again have a decentralized, user and control, secure, privacy-preserving, and scalable system. Very nice. So this works for tons of different things, not only KYC. We work with people in banking and accounting. We work with media. We can use it for digital signatures. There's lots of healthcare applications to it. You can use it for NFTs. Also, NFTs can have an identity. Tons of things. Also, machine identity, having very interesting projects there. Some of our partners in the blockchain ecosystem, but also outside the blockchain ecosystem is, for example, Deloitte, as I said, but also Frequency. That's a social media based on blockchain. DENA is the German Energy Agency. Public Pressure, you've probably heard about. They're doing music NFTs. Nova Wallet, you probably know when you are in the Polkadot ecosystem. Axel Springer is a big publishing house. So we're working with different types of people on different use cases, and you are more than invited to also become part of the ecosystem, because there's much fun and there's also money to earn. That was basically what I wanted to say. I'm not sure if I stayed in the 20 minutes. Thank you. Do we take questions? Oh, so is there questions? No questions. Oh, one question. First row.
How do KYC verifiers handle the user data?
How do the KYC verifiers handle the user data? So the verifier is, in that case, the Mary, right? So Mary receives the information that that this guy is born that day. How does she handle it? I don't know. And I don't really care, because it's just Mary. So how's Mary going to do something bad on that? If she wants to build a customer database just out of the information that people are over 21, good luck to Mary. So there's no incentive actually for Mary to collect all this data. So the verifier is actually pretty secure by itself, because there's so many verifiers. Because you go to one whiskey shop and you go to another whiskey shop next day, and they probably won't collude against you. So was that answering the question? I'm not sure.
Yeah, kind of. But how the verifiers are basically handling in trustless way? Can they handle the data in a trustless way or in a verifiable way where user can verify that your data after verifying
Yeah,
is
that's
getting
now the question becomes really cool because so how do I know if I'm talking to the right verifier? That's also a very interesting question. And does the verifier actually can I trust the verifier and how they handle the data? So normally the verifier will handle data in a database way or not at all. So if they're not really interested, they will just look at the data and throw it away. If they want to collect data, then of course they can do that in a database. And then it would be a really interesting question to first ask the claimer, which is Archie, to first ask him if he really wants to share, and also make sure that he knows the DID of the verifier and that he knows where he actually left his data and that he's possibly able to look at terms and conditions that they have, right? So that is something which is also already implemented. There's new standards emerging in the DID and verifiable credential like community about that. We are going to implement that for KILT in the next year. So we see that this is something that that people want. I don't see it absolutely necessary, but it's a cool thing. So this is going to come up. There's standards emerging around that. Okay, cool.
Any more questions? If somebody's got the questions, you
One
can
more.
please ask.
Yeah, so my question was, is there a way in the future where instead of telling Mary my birthday, I can just, or we can just give her the answer of yes and no, right? I don't have to tell her my birthday for her to know I'm over 21.
Yes, that depends on the type of credential. So if you have a credential which is a normal KYC credential, this will probably hold a date of birth. But of course, you could also have, you can ask, for example, the KYC provider, because I always have the problem that I want to show that I'm over 21, but I don't want anyone to know exactly how old I am. I'm not sure if, this is a, this comes up all the time, this question, but it doesn't. It's not really a very important question, I think, because people don't really care about it, and it's not very much improving the system that we have today. When I show my passport, there's also the real birth date on it, and it's not like, yes, this person is over 21. If you want to have another credential, which is an over 21 credential, you can just generate this credential. It doesn't cost much, like I think $5 or so to create such a credential, and then you can issue it yourself. You can ask your KYC provider to issue that credential, and then you just show that credential without any other information. That is also possible. So, or maybe to bring the other answer, zero knowledge is not necessary here.
Okay, but I mean, for this example, I understand, but what if we're talking about bank statements or bank balances, and I want to show that for loans or something like that? I don't want to show how much money I have, but I want to also prove that I have enough, right? So sometimes it does matter, like for bank
Exactly. There's so in the financial world and also in the military world, there is very important things that you can actually solve with zero knowledge proofs. On top of that, we had a project together with a partner company from China. They were doing that on Starks. The problem with blockchain and zero knowledge is always that you don't want the blockchain to calculate it because it's too heavy. So somehow you have to put it on the clients. And this is where Starks normally come in. Interesting project. Actually never found any use cases as far as I know, because the use cases of zero knowledge and credentials are, they're rare, and probably it is not because making new credentials which just have the information in there that you own enough money for that. Making new credentials or using selective disclosure on credentials that are already there is so much cheaper because it's all built in than creating expensive technology. And expensive, I mean, from computation power. that I'm not sure if zero knowledge proof and the credentialing system will ever really come together.
Okay, thank you.
Well, I'm sure we can go ahead with a lot more questions, but with the interest of time, we'll stop the questions here. And if you have a lot more questions, you can. I believe you'll be available to answer those during the breakout,
I'm
during
here
the
all day
lunchtime.
long, no worries. So just catch me.
Thank you so much, ladies and gentlemen. Put your hands together. Give a big round of applause to Ingo.